Hi, so good morning, class, or actually, good afternoon, class. So for today, we will be tackling nomenclatures of alkanes. So, bakit ko ba uunahin na ituro muna yung nomenclature of alkane? So, by nomenclature of alkane, this is actually the basis for naming other organic compounds. So, in that, if we mastered or we were able to name basic alkanes or even complex alkanes, we will be able to name other organic compounds. So, yun yung una ko munang naisip na gawin natin ngayong araw or ituro ko ngayon sa inyo ngayong araw para maging adept na tayo sa pagpapangalan ng mga organic compounds natin. So let me just check kung nag-record na po yung okay, it's recording. So on that, let's start with the common names muna. So basically, when we talk about alkanes, we have what we call scientific or systematic way of naming organic compounds. We also have what we call common names or trivial names. So by trivial names, these names are actually names that is something, it is usually to name something upon its discovery, which is usually decided by the discoverer. Meaning to say, yung discoverer or yung naka-discover, yung nagbibigay ng pangalan or nag-decide kung ano yung ipapangalan dun sa ating organic compound. For example, we have here urea. So, bakit naging urea? Because it is a compound that is isolated from urine. This is urea is actually a fertilizer. So, ayan. So, naisip nung discoverer na pangalanan siyang urea kasi derived siya from urine. And another thing, we have here morphine. Morphine is a painkiller. So, it is named after the Greek god of dreams, Morpheus. Hindi ako sure kung ano yung direct na analogy niya kung bakit niya naisip na yung painkiller ay related sa God of Dreams. But we have here Morpheus, thus morphine. Another thing is we have here the barbituric acid. Barbituric acid is a tranquilizer. So barbituric acid is named after the discoverer's friend, which is Barbara. So, lagyan ko lang ng comma. Para hindi tayo magkalito ba? So basically, yun yung way ng pag-name or pagbibigay ng name sa ilang organic compounds natin. So for alkanes, we there is actually a system on what in which common names are given to our organic compound, in which uh, alkanes and common names of alkanes are actually decided by the number of its carbon atoms. So, for example, here we have here if the compound or the hydrocarbon, which is alkane, has one carbon atom, it is methane. If it has two carbons, it is named ethane. And we have here propane for 3, butane for 4, and so on and so forth. So this is how we usually name alkanes. But in some scenario, we have alkanes that have different structures from one another. Meaning to say, nagpapalit-palit yung arrangement kung paano nakakabit yung mga carbon atoms sa kapwa nila carbon atoms. So, nagkaroon pa ng iba pang ways kung paano tayo magkakaroon ng common names ng ating alkanes. So basically, we have here a table that you may want to memorize. I hate saying this, but you need to memorize this one. So we have here methane, ethane, propane, butane, pentane. That will be easy. Pent means 5. Hexane, 6. Hep, which is 7. Oct, which is 8. Non, which is 9. And 10, which is dec. So, medyo dito na lang tayo magkakaroon ng problema when we have alkanes with 11 carbon atoms and above. So, but basically, there is system, or what we call here a pattern, which is we have here undecane, which is from the word uno, one. Undecane, we have do, decane, do, die, so which means two. We have tri, which is three. Tetradecane, which is tetra, means four. We have pent, hex, hep, octa, nona, and we have the aso, eco, ecosane. So in that, as I mentioned, we have different classes or different structures on how each of the carbon atoms attach to one another, especially for those alkanes which has carbon atoms which is greater than 3. So, in this, some alkanes beyond profane or alkanes with more than 3 carbon atoms, which means butane, pentane, hexane, heptane, octane, nonane, and decane, and so on, may have different prefixes for their common name. This is based on their structural isomers. So, ay, no, this is not differential, it's differentiate. Sorry for that typo. So, if we have a continuous chain, meaning it is just tuloy-tuloy lang siya, wala tayong tinatawag na branching, we use the prefix normal or n dash, don't forget the dash, for indicating the continuous chain. So, pag meron na tayong branching, dito na papasok yung ating ISO and NEO. So, ISO is used for indicating that one end terminates in a C32, which means we have two metal groups there, CH group. And for NEO, we have here for indicating that one end terminates in three metal groups, which is attached to a single carbon atom. So, in that example, let me present it in a way na mas visualize natin. So, let's use pentane, for example. Hi, class. So, in that example, I said earlier, let's take pentane as our example. So as you can see here, pentane we have here 5 carbon atoms. So we have here 1, 2, 3, 4, and 5. So for a pentane, ganito yung itsura niya. As you can see here, we just have a continuous chain. So, isang diretso lang. Isang diretso lang yung ano natin, yung pentane. That's why for common names in terms of alkanes, this is what we call an N-pentane. Or based dun sa slide natin kanina, it is just normal pentane. So when it comes to the second one, as defined kanina, ang sabi niya, we have here a termination wherein we have CH3 na dalawa or metal group na nakakabit dun sa terminal na carbon natin. So meaning to say, if we have that what we call isopentane, so for this case, hindi magbabago yung number nung ating carbon atoms. Magbabago lang ay yung kanyang arrangement. So for that said arrangement, kunin ko lang muna ito. So, we have two metal groups for this case. So, ito yung isang metal group natin and isa pang metal group. By metal group, we have here we have isang carbon atom. So, in that, if we reconnect that to our structure, okay, as you can see here, magkakaroon tayo ng chain. May continuous chain pa rin tayo. So, kita niyo ba yung continuous chain? Wait lang. So, for the continuous chain, andito, yung continuous chain natin, meron tayong 1, 2, 3, 4, 5. Kung makikita mo, pentane pa rin siya. But for this case, meron na tayong tinatawag na branch chain. From this parent chain, itong tatlong to, okay? Dun sa tatlong yan, okay? Nagkaroon tayo ng branching dito sa part na to, okay? Wherein from this carbon atom, meron tayong first branch dito sa taas and another branch dito sa baba. So, yan yung tinatawag nating isopentane. So, kung kayo ay familiar dun sa mga usual na rubbing alcohol natin, meron tayong tinatawag dun na isopropyl alcohol. So, parang ganun lang din yun, ano. So, ang nangyari lang dun sa isopropyl alcohol, meron lang tayong OH na functional group. So, let me just get that OH. So, we have here our oxygen, which is red, okay? And our hydrogen. So, we have here our hydroxyl group, okay? Then, we have here our propyl. Nakikita nyo? Bipropyl, tatlong carbon atoms. Then, we have a bunch of hydrogen here. So, this is how your isopropyl alcohol would look like. We have here an OH group and we have here our propyl group. So, iso, kasi meron tayong CH3, then meron tayong C dito, CH. Kita nyo ba yung CH? Yung CH, then we have here our functional group here. So, going back to, pakita lang natin, so that will be isopropyl alcohol. Okay? Or isopropanol. So, ayan. Or propanol, hindi isopropanol. So, going back to our pentane. So, the last example of our pentane is the neo pentane. So, for the neopentane, ang nangyari lang doon, ang sabi niya, meron tayong tatlong metal group, which is CH3, that is attached to a terminal carbon. So, let me just construct that. So, bali ang nangyari doon, meron tayong C, sabi kanina. Yung C natin, naka-attach siya ron sa isang metal group. Okay? Tapos, dito sa C na to, sabi niya, meron tayong CH3. Okay? Meron tayong CH3, then C, tapos yung ating natitirang alkyl group, which is itong isang ta. So, what will happen here is we have here this metal group. And again, we have this metal group. Okay? And the last one here, we have here our metal group. So, kung makikita natin dito, we have here one carbon atom dun sa center natin and napapaligiran siya ng ating metal groups. So, this is our neopentane. Okay? Hopefully, malinaw yung, yung naming natin or yung tinatawag nating common names ng ating mga alkanes which has more than 3 carbon atoms. Okay? So, going back to our slides, having that discussion regarding what we call common names of our organic compounds, and we have here yung ating neo, iso, and medyo magkakaroon tayo ng problema pag sobrang laki na ng ating chain or sobrang haba na ng chain natin. So, in here, we will be discussing another way of naming organic compounds, which is called the IUPAC system or IUPAC system of nomenclature. So, for those na hindi pa rin naaalala kung ano yung IUPAC, this is the International Union of Pure and Applied Chemistry. So, that is our IUPAC. So, under IUPAC system, bakit nga ba kinailangan na magkaroon tayo ng ganitong system of naming organic compounds. So, simple lang. So, why to use IUPAC naming or IUPAC naming? Because there is a boom. There is 19th century Eureka moments boom in that. Sobrang dami nung nag-discover. There is a lot of organic compounds that are being discovered during that time. So that's why sobrang dami nung naging organic compounds. Ang hirap na puro common names yung gagamitin natin. That is why IUPAC naming is established during that time. It is, kasi nung time na yun, nung 1892, doon nagkaroon ng mga committees, nagkaroon ng commissions on how to name this compound. Yung parami na kasi ng parami, tapos lahat sila, isipin nyo. For example, we have their pentane. Pentane can take up different shapes or different structures. So, how do we name them? Ang hirap naman na lahat sila ay neo at iso. Tapos lahat, papangalanan mo ng N-pentane. Paano yung mga N-pentane na naka-attach sa ibang functional groups? So, paano natin papangalanan yung mga yon? So, they came up with this IUPAC naming or systematic way of naming. So, in that, systematic names is actually made up of these three parts. We have here the prefix, the stem, and the suffix. So, for alkanes, medyo madali pa yung kung paano papangalanan ito. By prefix, this is just a description of how the structure would look like. Siya ba ay di, tri, siya ba ay cyclo or nakacyclic ba siya in some way. And for the stem, we have here this system. So by stem, it indicates the number of carbon atoms that are in the backbone. By backbone, this is actually what we call the parent chain. And by parent chain, this is the longest chain or the longest continuous chain of carbon atoms in an organic molecule. So, dun sa example natin kanina, dun sa pentane, dun sa N-pentane, dun sa ating isopentane, and dun sa neopentane, kung mapapansin nyo actually, nagiging maikli yung chain natin. Okay, nagiging maikli, which started with a continuous chain, which is 5. Then, for iso, we have there a pentane that has only the longest chain, which is 3. And, nga ba? 4. 4 yung longest chain natin, and for the neopentane, our longest chain is 3. So, for the IUPAC system of naming or IUPAC naming, N-pentane, isopentane, and neopentane will have different names. By different names, N-pentane will be just pentane. Then isopentane will be 2-methylbutane. And neopentane will be dimethyl profane. So yun yung mangyayari. So, but in any case, when we talk about IUPAC system, we will be looking at the backbone. Again, backbone is the parent chain of our organic compound, and by parent chain, it is the longest chain or the longest continuous chain in our organic compound. So, for that backbone, if we have one carbon atom that will be met, okay, that will be the stem of our organic compound, which is met. Then we have it. If we have 2, for C3 or 3 carbon atoms, we have pro. And for C4 or 4 carbon atoms in the longest chain or backbone, we have butane. and so on. So we have their pent, hex, hep, oct, non, dec, undec, dodec, tridec, tetradec, pentadec, hexadec, heptadec, octadec, nonadec, and ACOS. So, the system remains. By system, yung sinasabi ko kanina ay yung indication natin or yung kung paano siya natutulad dun sa paano natin pinapangalanan yung mga alkanes natin. So in that, that goes our naming for the stem. So, magkakaroon to ng sense mamaya. Huwag kayong mag-alala. Ituturo ko sa inyo kung paano yung gagawin. So, for the next part, we have the prefix, then we have the stem, and let's have the suffix. So for the suffix, it identifies the type or class of the organic compound. So for alkanes, we use the suffix "ane". For alkenes, we use the suffix "in". For alcohols, we use the suffix "ol". For ketones, we use the suffix "non", minsan "anon", minsan "on". So, and more for other functional groups. So, however, for some alkyl groups that are characterized as a side chain, we use "il" instead of "ane". So, ano ba yung ibig kong sabihin dito sa "il" na ito? So, for example, I have what we call our neopentane earlier. So, let's have our neopentane. As you may have remembered, our neopentane has a C or a carbon atom which is attached to three metal groups. So we have here CH3, okay, and we have here another CH3. Okay. So in this structure, as you may see here, we actually can have a parent chain which is this one. By parent chain, this can be the longest continuous chain in our organic compound. Pwede rin namang itong part na ito, or pwede rin namang yung isang diretso na to. But as you can see here, we have here metal groups that are not part of the parent chain. So for the red one, as you can see here, let's focus on the red one, the red chain. We have here this CH3 and this CH3. And this CH3 are not parts of, it is not a part of the parent chain or the backbone. Meaning to say, these two metal groups are what we call side chain. So for alkyl groups or alkyl alkyl functional group, which is the aliphatic group, we will be identifying this one as side chains, and instead of using methane, we will name this two as methyl. Okay, so we'll continue in this later on the next part of the video. Let me just pause for a while. I have another class. Alright, so hello again, class. So, going back to our discussion, I just finished my class with you in Physics 3. So, here's a continuation for our uh, the discussion regarding the suffix or for alkyl groups. So, in that, let me just introduce you to the different kinds or different aspects or different examples of what we call alkyl groups or common alkyl groups. So one example of an alkyl group that we may use usually is the alkyl group with this structure. So we have here CH3 dash. So this metal group is what we call, or alkyl group is what we call a metal. Also, we also have this metal group. This can also occur as a side chain for our backbone. So since we have here two carbon atoms, we call this an ethyl. Also, if we have this structure, we have CH3, CH2, CH2, and this is bonded to backbone. As you may see here, we have here three carbon atoms, which means this is a propyl. Okay. So earlier, we also introduced the common names using N, ISO, and NEO. So for this example, we can have the side chain with a CH, which has two methyl groups that is attached to that CH. So, and this middle carbon is attached to a backbone. This is actually also a propyl due to the existence of three carbon atoms. But since this terminal chain has two methyl or two carbons that is attached to our carbon here, so which means this is actually an isopropyl. Just like our example earlier regarding the isopropyl alcohol or isopropanol. Also, we can also have here our butyl. So we have here CH3, CH2, which is bonded also so CH2, and we have another CH2, and this whole chain is connected into a greater chain or what we call a parent chain. So we have here our butyl. Okay. Also, we can also have an isobutyl, wherein for our isobutyl we will have here our CH, then we will have here our CH2. This will be attached to our R group or our parent chain. And we have here two metal groups. We have here the CH3 and the CH3. So for this example, we also have here four carbon atoms, which mean this is a butyl. But due to the structure here, since we have here two metal groups that is attached to a carbon atom, so this is what we call an isobutyl. Okay. And also, we can have what we call a sec-butyl. So for the sec-butyl, this will be its structure. So we will have here our carbon that is attached to our parent chain. This carbon that is attached to our parent chain will have a metal group that is attached to it. And we have here our CH3, CH2, which is an ethyl group attached to our carbon here. So as you can see here, we still have four carbon here, which means it is butyl, and it is called sec butyl. So you may be wondering why it is called sec-butyl. So for sec-butyl, we actually look into our carbon here. It has a different structure with our sec-butyl because in our isobutyl, because our isobutyl, the metal groups are attached to the terminal carbon. Okay. But for this example, our methyl is actually attached to the carbon that is nearer, or in some sort, it is nearer to our R group or kung ano mang group na nandito. Okay, so that is our sec-butyl. We also have our tert butyl. So our tert That means tertiary. So what will happen here is we have here our carbon group, or carbon. In this carbon, we will have uh, three metal groups that is attached into it. And this carbon is attached to our iron group. So this will be our third butyl. Okay. So here are the examples of some of the common alkyl groups that are usually attached to a parent chain as a side chain. So remember lang class, this form of naming or this method of naming our carbon compound happens for our side chain. So mamaya, as we go along the discussion regarding the IUPAC way of naming organic compounds, this side chain will make sense. And some more examples. You may pause the video if you're not done copying these examples. And we will have here other examples of our side chains. We have here our CH3, CH2, 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 and CH2. If this is attached to a side, as a side chain, we call this pentyl, much like how we named the past side chains. So also, it can occur that if we have here our CH, and there are two metal groups that is attached to that C, and we have here two other carbon atoms as part of the side chain. As you can see here, we have uh, one, two, three, four, five carbon atoms, which we on our terminal carbon we have a branching of two metal groups. So this will form what we call an iso, and we have five carbon atoms. So that means that it is pentyl. So we have here our isopentyl. Okay. So those are some examples of our common alkyl groups that serve as our side chains. And moving forward to our nomenclature, here are actually some the steps in naming our organic compounds. So in here, we will focus on naming alkanes, but it follows the same steps. Meron lang konting mga pagbabago regarding the suffix that we use depending on the functional group that is present in our organic compound. So basically, we have here four steps. These are the four steps. First, you need to locate the parent chain, and by parent chain, you must find the longest chain and use the name of the chain as the parent name. And for letter B, if there are two different chains of equal length, choose the one with larger number of branch points. Okay? Branch points ang titingnan natin, meaning to say, we will look into the number of side chains. And for number two, we need to get the number or assign number of atoms in the parent chain so that the substituent are given the lowest position numbers. We will look into that later. And identify the substituent and the position of carbon atoms to which they are attached. If there are two substituents on the same carbon atom, assign them both the same number. There must always as many numbers in the name as there are many substituent. So if we have four side chains, there must be four numbers in the name. And lastly, we have here write the name of the compound by first arranging all substituent in alphabetical order, A, B, C, D, E, and so on. and preceding the name of each substituent by position number, then adding the name of the parent chain. Use hyphens to separate the different prefixes and commas to separate numbers. If same alkyl groups occur in one more once as a substituent, indicate by prefixes. Ito na yung sinasabi nating prefixes kanina. So kung meron tayong dalawang methyl, we will write there dimethyl. If we have three methyls, we will use trimethyl. If we have tetra, we have four, we will use tetra. And if we have five, we will use penta. So, however, do not include this in alphabetizing. Meaning to say, if we have three methyl, three ethyl groups and two methyl groups, that will be diethyl and dimethyl. So we will not consider the naming of the di and tri or the prefixes. So the arrangement will still be uh, triethyl, dimethyl. We will look into that later. And for the prefixes such as cyclo, neo, iso, it must be included in alphabetizing substituent, while the prefixes, hyphenated prefixes such as third, sec, and are ignored. So, hopefully, this will make sense later on. So, in that, let's first start our example with, uh, let's say, an easier example. So, say we have here this structure. So, we have here CH3, then we have CH, then we have CH, then we have CH3. Then in this CH, we have here CH3. And for this CH, we have here CH3. So for the bonds, we will have 1, 2, 3, 4, 1, 2, 3, 4. Because for carbon has 4 valence electrons, so you need to keep that in mind that for each carbon, there must be 3 other atoms that is bonded to it. So it looks great. So for this example, the first step that was stated to us is first find the parent chain. So for the parent chain, we just need to count yung pinakamahabang continuous chain. So it can be 1, 2, 3, 4. Okay, that's 4. It can be 1, 2, 3, 4. Okay, 4 yung highest pa rin natin. So we have 1, 2, 3. So it's less. So let's disregard that. It can be 1, 2, 3, 4, and also 1, 2, 3, 4. In any direction, the greatest or the longest chain would be 4. So in that, we will have here, since all of this are single bonded and all of this have only carbon and hydrogen, this will be butane. Right? So that will be our parent chain. So we have here our parent chain, which is uh, butane. So let's just encircle our parent chain so para hindi tayo malilito. So our next part is to give numbers to our carbon atoms. So we will assign their numbers in such a way that that the substituents will be the given lowest position numbers. So if we assign this as 1, 2, this will be 2. Okay, position number is 2. Again, if we use this 1, 1, 2, same. The position of this substituent will be 2. Okay, so in that, let's just write this as 1, 2, 3. Ay, 4, sorry. So in that, we assigned numbers for the carbon atoms. So ang kailangan na natin gawin ngayon is to determine our substituents. So we have here our side chain, which is a methyl, and another methyl. Meaning to say, we will have here a dimethyl. So we can write that as dimethyl. Okay. So as you may remember earlier, we need to identify the numbers or the position numbers of our subsequent or our side chain. As you can see here, methyl is actually attached to carbon 2 and another methyl is attached to carbon 3. In that way, we need to indicate that numbers in which we will write that as 2. Numbers will be separated by a comma. Remember that. And numbers and words or names will be separated by a hyphen. There is no space for this one. So basically, that should be 2, 3, dash, methyl, dimethyl, butane. So that is one example of our uh, naming. So let me give you this example. So you can try it. So we have here CH3 and we have here CH2. Then we have here our CH. We have here CH3. We have here CH2 and 2, 3, 4, 5, and let's end here. Okay? So try to pause the video and try to name this compound. Hopefully you're done. So in that, this alkane is actually named 3-methyl nonane. Sir, sabi niya, yung iba dyan, sabi nila, bakit po? Ang nakuha po namin, sir, ay 1, 2, 3, 4, 5, 6, 7, 8. Sir, di po ba yan ay 2-ethyl octane. As you may have remembered, we must use the longest chain. And for this example, our longest chain will actually be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that will be our parent chain. So the parent chain will actually be nonane. And we have here a substituent which is methyl, nag-iisa siya. So hindi natin siya bibigyan ng prefix. And that methyl is actually located at the third position, which is 1, 2, 3. Okay? So hopefully you have you have got that concept. So let me just give you other examples in which you can para mag-work to work with. Okay? So let's set this as our assignment. Ang alam ko meron na kayong assignment na nauna. So this will be due next week since our assignment is is due today, if I'm not mistaken, by 11:59. So if you don't watch the video, you won't hear this announcement. But anyway, here are some examples. Let me just stop the video here so you can just get back to this as the video restarts. Okay, class, I'm back. So we have here this three structures wherein you will be naming. Okay, so please use IUPAC naming for these three compounds. So maybe I will be getting the assignments or scheduling the deadline for this assignment on Wednesday. Okay, so due next week Wednesday. Okay, in that, thank you and have a nice day.